Thanks a lot. Thanks for the introduction. Thanks for the opportunity of being here to present the results of my research that I'm doing nowadays for more than 10 years of the impact of greenhouse gas emissions from wastewater treatment and urban drainage system. And here I just want to give you some examples of typical drainage system structures, how we balance the carbon dioxide itself. First of all, I would start with a short table of content about the motivation and introduction, the evaluation then of carbon footprints of different stormwater management systems, and some conclusions or some best practices that I would end with. First of all, the carbon footprint of the wastewater sector. Here I choose the example of Germany. All the carbon dioxide equivalent emissions from the wastewater treatment are less than 0.5% of the carbon dioxide footprint of a German citizen that he generates in general. Of course, this is quite very low, but it has a high effect in total. Okay, and the main question we should focus on is what are the main sources for the greenhouse gas emission in the wastewater sector? In general, we talk about wastewater treatment plants, and there, of course, we have the highest impact of the emissions or the direct emissions from the wastewater treatment plant, like methane, the loss of methane that we have there, and of course, the other high potential of the denitrous oxide that we have there. And of course, the other emissions from the operation and maintenance, the energy that we need in the wastewater treatment plant, and so on. These two big parts leads to more than 80% of the emissions of the wastewater treatment plant, and only around about 10 to 20% are from the construction of the wastewater treatment plant itself, and also for the machinery that we have there. And what are the main uncertainties in the water footprinting in the water and wastewater infrastructure that we have? Of course, the main procedures for the carbon footprinting are available. Here we have a lot of norms that we have a long time, but we're developing a new working sheet from the German water lines that it will be that will start in the next year, where we have a specific balancing frame for the carbon footprints of all products from the wastewater sector that we have, and how we can balancing all these specific footprints. Further, we have also further databases that we use for the emissions factor that we need. There are a lot of things that we have. I do not want to go in detail for all of them. Important for German and also for the European construction sites that we look for. We have the Probus database that we use, and the German Sustainable Building Council, where you get free of charge the emissions from specific working sheets that you use and you need for. Considering the sources of the carbon dioxide emissions, there are the three phases. On the one hand, the construction phase. There we have the emissions from, for example, from the construction machinery, the most important ones, the transport emissions, and of course, the raw material emissions. Also here are a lot of differences, which kind of raw material you use, where it comes from, and so on. And of course, the normal focus is on operation and maintenance. When you classically look on carbon footprinting, normally it's done for the operation and maintenance. Here in this presentation, it would be a little bit different. And of course, at the end, the demolition and disposal. And here also we can have a look. When we look for a classical wastewater treatment plant, there we can say, and we have calculated it in detail, this is less than 1% of the total annual emissions, what leads or what comes from the demolition and disposal at the end of life, for example. Here are some elements for sustainable stormwater management strategies. We have the pavement area with pervious surface. This is quite one thing. Then the other ones, the sewage trench, the streets are the parts, the purification facilities, water bodies, the discharge into the water body from the households itself, the retention that we have. Also the examples that we hear in some talks before, the roof area which is planted, the rainwater basins for the households and garden use. There we have a lot of possibilities what we can use for sustainable stormwater management, but what about the impact of the carbon footprinting of these elements in the wastewater strategy. Therefore, I just want to give you a short example about a comparison between a swale and a more or less decentralized retention basin that has and decentralized retention basin in Germany. On the one hand, we have a swale infiltration, which leads to an area of around about 2,000 square meters, and a stormwater retention basin that we need, which has a volume of 1,000 cubic meters in the same area. For the carbon dioxide footprinting of a swale, we used the so-called standard specification for the construction that we have in Germany and that you also know very well. Here, the important factor, we have the diggers for losing and digging, the transport in this case, and we have here the biggest part. This is the addition of calcium carbonate that we need for the soil itself in this specific case. But for you to see that the most important impact here comes from the addition of the calcium carbonate to which was needed for the soil itself. And so here you got in detail around about 42 kilogram carbon dioxide equivalent emissions per square meter when you use, or when you need the calcium carbonate. If you do not need it, it's around about just 9 kilogram. And also this leads to a specific annual emission factor between 1.4 up to 2.1 kilogram carbon dioxide equivalent emission per square meter and year. Here, the other one that we calculated in detail is stormwater retention basin that you can see here in the picture. It was around about 100 cubic meters. We have a sewer inlet structure that is quite additional to the swale that is necessary. This is quite very short in this case, but this leads to the specific boundary conditions that we have there. And the construction period for this case was 3 months. Here you see three different calculations for the retention basin here in Germany. The three examples are divided by a small digger and a very low transport distances, then a mobile digger, which is quite a little bit bigger, and a transport distance of 25 kilometers, and the last one we have 50 kilometers and a chain digger. For example, here you can see the construction itself leads to around about 12,000 or something between 11,000 and 12,000 kilogram carbon dioxide emissions. The diggering between 500 up to 3,000 kilogram. But the main, or one main source of the emission is, of course, the soil transport and also the transport to the construction site and the transport from and to the construction site. Then on the other hand, the sewer that we need and the concrete inlet structure just was around about 15 tons, and the inlet structure oriented to nature was around about 6 tons. But the main focus that we have always for our calculations is the transport and to minimize the transport distances to reduce the carbon footprinting of these specific facilities. Here we receive a specific annual emissions factor, which is around about, in the best case, 550 kilogram per carbon dioxide equivalent per year, but it could be leads up to 1,800 kilogram carbon dioxide equivalent per year, and this only by the different use of transport distances and the problem of the problem there. In this case, the example itself, what we look for, there is the calculation not really correct. We need a specific sewer inlet structure to bring in the water specifically. It was quite designed very in detail, and everyone thought in the beginning that it would be constructed on the construction site. No, it was constructed in Russia and transported to the specific case, and so it was a horrible footprint itself. Here, just to see the impact factor to go down for an annual emission factor for these two different systems. Here, the main driver is the addition of the calcium carbonate that we need for the swale. So we could not say always a decentralized system is good or a centralized system is the better choice. This has to be calculated for the specific targets then itself. But we have, of course, other possibilities to optimize the carbon footprint. And the main or the best thing to optimize the carbon footprint is the multifunctional use of the areas and facilities that we have. For example, we use as infiltration system terraces, parking spaces in due to the shops and so on, marketplaces. There, a direct infiltration is the best opportunity from not only from the look from the carbon dioxide balancing or from the carbon dioxide emissions balancing. Also, there are a lot of other advantages, but the multifunctional use is the best way. And also the swale as a green urban infrastructure and the combination, of course, of playgrounds and parks. And for retention basins and overflow basins, for example, there we can also use these parking spaces, low depths, what we need for storage, and to look for a dry access for the cars. Also, marketplaces could be possible with the specific depths, what we look for. And of course, public parks, or on the other hand, also streets would be available therefore. Here are some best practices that I want to show you at the end of my talk. It's the multifunctional use. Here we are a stormwater management in Kaiserslautern. It's from the Atelier 3 Seite. It's only one good example that I have from Germany. The other ones are from the Netherlands because they are here the leaders of the world, more or less. Here we just see the multifunctional use of the water. Just for example, here a runoff during a heavy rain event that we have from these specific parts. The water squares in Rotterdam, it's quite a very interesting idea for a multifunctional use of these different areas and a different, under different conditions. For example, here is the conditions how the water flows up or how the water runs up during the different situation. On the first one, we have here the dry situation. Here we have a medium rainfall, and the last one where the area is flooded. It's round about for 1 year storm. The next one is the changing waterscapes in Singapore. It's also from an architecture consultant here from the Netherlands, from the Urbanisten. And here you can also see the multi-use of the different areas and also the use of the water. Here we have the stormwater sewer, or the stormwater sewer, the outtake, and to get the water again to the surface. We got here the canyon, and then just at the end an existing basin to reduce the water intake and also there. That would be the end of my talk. Thank you for your kind attention. Here are my contact details, and I hope you have some questions.
Thank you for your presentation. Well, interesting to see how the carbon footprint also can be used in the selection process or decision-making process to decide on certain constructions. That's the message what I got from your talk. Is that correct?
Yeah, that's correct.
Any questions from the audience, please? Yes.
Thank you, Dr. Schmuck, for your presentation. I was wondering about the need to add calcium carbonate to the soil in the case of the swale, because in a natural situation where there would be no impervious area, the rainwater would have infiltrated anyway without calcium carbonate. So what kind of environmental objective do you have?
In this specific case, there was the problem that the infiltration velocity was too high, and so therefore they need an addition of the calcium carbonate to change it a little bit. But this was just specific to that case, but I thought that it was so interesting that we just looked sometimes for some tiny screws which could have a huge effect. Another example, therefore, could be, for example, I balanced a specific construction size for a wastewater treatment plant for the office building. And there they just changed the facade to a specific architecture. It was a specific, it has specific colors and a specific shining effect. This raised up the carbon footprint of more than 500%. Just the change in the facade, not in anything else, just this tiny part. Okay, and so this could always have a huge effect.
Another question in the back over there.
That was interesting. I'm very curious about the slides you were showing about multiple ways to use the same space, particularly I think it was Rotterdam. So we had a view where it was flooded and was, well, dry and see children playing around or something. So what are the different uses of that space? Because I wasn't sure what the green thing meant. What did they do? Did they cultivate stuff? What was it?
Sorry, once again,
There was a view where it was completely flooded.
Yeah.
Another one where it was partially flooded. What was the difference in the way they were using the space in these cases?
Yeah, okay. This is quite, for example, on the one hand, there was, or the idea is that we can use it as a playground, and sometimes we give the allowance to have depths of 5 centimeters as an idea, just where you got wet feet, but nothing more, so then you can use it, but on the other hand, you couldn't use that place again. So it's just the idea. I'm not sure if it's quite
maybe during the lunch break you could have a closer look at the pictures, and then you might explain. Or maybe there are other people in the audience that can tell you more about the Dutch examples. Any other questions? Well, I have one, and it's just for clarification because that was not clear to me. You express the carbon emissions in annual emission factors.
Yeah.
Why is there the dimension time? Because you look at the carbon, as far as I understand, you look at the carbon release during the production. Why is there a dimension time?
Yeah, this is quite a good question because in general, normally we would say the emissions are leading today, and so we have to balance them today. That's correct. But on the other hand, it's to receive a full picture of the system, we need the factor time, because on the one hand, when I constructed something that only has a lifetime of 5 years, you couldn't combine it with something that has a lifetime of 50 years or something like that. And so it would be annual. This would be one possibility. The other one would be 100 years that you maybe know better from the cases of the carbon balancing itself and the lasting time in the atmosphere. So, and we choose the one once a year.
Okay, so you spread the emission over a certain time period.
Yeah.
Okay, that's clear. But you still do not include, let's say, the footprint during the operational phase of.
This we also have, but now the talk just should be about the gray emissions.
That's not included in the examples that you showed. Okay.
Yep.
That explains it a little bit for me. Any other questions?